And now we're gonna talk about Factorial ANOVA. Remember, with the Factorial ANOVA, we have multiple factors in comparison to the simple or one-way ANOVA. When we were talking about one-way ANOVA, we had one independent variable or one factor that had multiple levels, 3 or more levels. And to that, we can actually add a different factor or a second independent variable, which may have 2, 3, 4, 5, or more levels. And we wanted to see if the second factor has an effect or an impact on our dependent variable. If we have some information here for students who some of them have been mentored and some of them have not, and they actually have enrolled in different schools. So we can look at the school as one of our factors that has multiple levels. I think we have about 4 or 5 different schools that we have information for. And our second factor, our grouping variable, which is whether students received mentoring or they did not. And we have multiple dependent variables that we might be interested in looking. So for now, let's focus on the final GPA. When we're doing Factorial ANOVA, we're looking if there's an impact or an effect of factor 1, which in our case is school, or if there's an effect of factor 2, in our case group, as well as if there's certain interaction. The interaction represents if there is a different pattern across one of the variables based on the other. So for example, we want to see if there are different patterns for mentored and non-mentored students across the schools. So for example, if in one school the mentored student had higher GPA than the non-mentored student, and then in our second school the mentored student had lower GPA than the non-mentored student, this will have a different impact. And we can see that visually, which can be really, really helpful. So let's get started and run the Factorial ANOVA. We can go under Analyze, down to General Linear Model, and we're going to click on the univariate option. Under Dependent Variable, what are the variables that we're interested at? In our case, it's the final GPA, and we're looking across schools and across groups. These are our 2 fixed factors or our 2 independent variables. Let's see if we can get SPSS to show us visually what those patterns or trends look like. So we can click on plots, and let's say that I want groups to be on my horizontal axis and schools to be as separate lines. And these don't really go in certain order. You can flip them around. And we can click Add. So that's the plot that we're gonna see. It's grouped by school. And for now, we're gonna click OK. And here's our output. So first we have a description of our factors. So our first factor was school. We had 5 different levels, so students were split up across 5 different schools. And also we can see how many participants do we have in each school. Also, our second factor we had was the grouping variable, whether students received mentoring or not. And we can see that that factor has 2 levels, the mentor team and the control group. and we can see how many students again we have in each group. The table below is our main table, and when we talk about Factorial ANOVA, there are two main definitions or two main important things that we look at. On a factor level, whenever we're talking about a single factor, like for example school, or group by itself, we're talking about a main effect. So whenever we're doing a two-way ANOVA, we're also gonna have two main effects, one for each of the factors, and we also are gonna talk about interaction, which is the interaction between those two factors. So here's our interaction term that look the multiplication of school by group, and here are main effects, the main effect of group and the main effect of school. And across we can see if our main effects are significant and if our interaction is significant. Usually the first thing we'll look at is to see if there's an interaction, because the interaction is more interesting. If we have different patterns across groups, which is what the interaction tells us, it may not be so important to look for the main effects. So here we have the interaction between school and group. We can look across, and this is a significant interaction. So we may not be interested in looking at the main effect of group, which is also significant, and the main effect of school, which is significant as well. And here's what the interaction looks like. Usually a good way to represent an interaction, or to see that there's actually one, is if we look at the lines. If there is any crossing lines, that may be a good indication that there's an interaction going on. So what is happening is we have a really huge changes for these schools, the blue one which is Calvert, the green one which is Fulbright, and the purple one which is Wilburn. The other two schools are almost flat, so there's almost no change or no difference between the mentored and the control group. Because of these different slopes, and they're very different, realistic versus almost flat, that leads us to think that there is an interaction or there's significant differences across those patterns based on the school and the group variable. Now, whenever we have Factorial ANOVA, we're going to have multiple F values or multiple obtained statistics, just because we have multiple factors. So we're going to have one for the interaction, one for the first main effect, and one for the second main effect. And here's where we're going to take our degrees of freedom. This is an F value, so we're reporting it exactly the same as before. So for example, the F value for the interaction is going to be F with degrees of freedom of 4 and 372, which is our error term, is going to equal to 3.62 with P less than 0.05. If we further want to see where those differences are, we can do a post hoc test similar to how we did it in just a simple one-way ANOVA to see where those differences actually are.